Today we're going to be talking about volume in our molar calculations. So today you need your note set, you need your calculator, a Y diagram, and for after you're going to need the homework that I showed you guys yesterday that says volume and mass. Alright, so to start with, every gas behaves exactly the same under the same conditions. This is important to know because it doesn't matter what the gas is, it's going to behave exactly the same. So if I had a balloon filled with 1 mole of oxygen molecules, it'll be the same size as a balloon that's filled with 1 mole of, let's say, helium molecules or atoms. This is true as long as they are at the same temperature and pressure. All right, same as long as they're at the same temperature and pressure. Because we do know that if you increase the temperature, a balloon would expand in size. If you increase the pressure, a balloon would shrink down in size. So we have to keep those two things the same. As long as those are the same, then our gases will behave exactly the same. So that brings us to our next slide here. Molar volume is the volume in liters of 1 mole of any gas at STP. STP stands for standard temperature and pressure. Again, I have to keep those two things the same, otherwise that'll change my actual value for the volume. So standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. That's at sea level. So these two conditions are important for you to know because if I change those conditions, then the volume I'm about to tell you won't actually be accurate. So this volume for 1 mole of any gas at standard temperature and pressure is 22.4 liters of space. So again, as long as I know that it's at standard temperature and pressure, 1 mole of any gas occupies 22.4 liters of space. Well, so what are the two conversion factors? Well, that's easy. Just like we've taken all of the other things and converted them, we're going to do the same thing here. 1 mole of our gas over 22.4 liters, or 22.4 liters over 1 mole. And then you just have to decide which one you're going to use based on what you start with. I would use this one if I start with liters. I would use this one if I start with moles. All right. So let's just do a couple of quick examples and then you can be on your way here. Remember, as always, you can use this Y diagram. We're going to be focusing on this volume section of it today. All right. So the first question here is then at standard temperature and pressure, how many liters would 0.430 mole of carbon dioxide occupy? Sorry. So real simple then, we start with our known 0.430 mole of carbon dioxide, and I am going to switch that into volume. Volume is liters. So now I just have to go back to my little diagram here and see. I started with moles. That means I want the conversion that cancels out moles. I'm going from moles to volume, so I want the conversion that cancels out moles. That would be 1 mole on the bottom, 22.4 liters on the top. Since that's on the top, I am going to multiply or multiply. So I'm going to take 0.430 times 22.4. I get 9.632. So I'm just going to change that to make sure it has the same sig figs as this, which has 3. So 9.63 liters. So that's a one-step conversion. That's what we've been working on. I'm going to throw in here a second problem that makes you go 2 steps. So let's take a look at this one. How many liters of space would 45.0 grams of carbon dioxide occupy? Okay, well now I'm going from grams all the way to liters. So if I actually take a look at my Y diagram, I'm going to start with grams, and I have to get to liters. So I'm going to have to follow the path that takes me to moles, which means I need this guy right here. And then I'm going to have to follow the path that takes me from moles up to volume. That means I'm going to need this guy over here, step 2. So you can use the Y diagram to do 1-step or 2-step conversions. Right. So I'm going to go back through here then. You can see I want to cancel out grams, so my grams is going to go on the bottom. 1 mole always goes on the opposite side. Grams of what? Well, it's carbon dioxide. So I need the molar mass of carbon dioxide. So I've got 12 for carbon plus 2 times 16 for oxygen. And that's 44 grams. So that is the molar mass. And that guy goes here. I mean, you can see from this that I did not cancel out the unit moles, and I want to get it into liters. So I definitely have one more step here. So that step is going to have to cancel out moles, which means that I have to put mole on the bottom. 1 mole, 22.4 liters. All right, well, how do I solve this? The same way we solved any of them before. If it's on the top, you multiply. If it's on the bottom, you divide. And you just take them one at a time. And I go on to this one. If it's on the top, you multiply. If it's on the bottom, you divide. So let's just do this on my calculator here and see what we get. 45.0 times 1 divided by 44.0 times 22.4 divided by 1. I get 22.9. Again, go back and check sig figs. We have 3 sig figs there, so 22.9 liters is a great answer. The next thing that we have to talk about is density. And again, you can pause or go back at any point here. But we do have to bring up density. See, density of gas is unique because I don't need to know the mass or the volume, even though the formula calls for mass divided by volume. I know if I have 1 mole of any gas, if I have 1 mole of any gas, I know the mass of that and I know the volume of it. Density for any gas is the molar mass over the molar volume. And the molar volume is always 22.4 liters. So this is great. All I need to know in order to do this, in order to find the density of any gas, is I just need the molar mass, because I know the molar volume. It's always the same. All right, so going on here, it says, what is the density of carbon dioxide gas? So that's going to be the molar mass over the molar volume, which we know is simply the molar mass over 22.4 liters. Well, we just did that for carbon dioxide on the last problem. I know the molar mass is 44.0 grams, and the molar volume is 22.4 liters. So I just divide those two things. 4 to 4 divided by 22.4. And that gives me 1.96. I mean, just go with 3 sig figs all the time for these. There's nothing that we measured. These are both actual constants that we use on the periodic table. They're rounded, so just go with 3 sig figs. And my unit does not cancel out, so it's 1.96 grams per liter. Let's go on to the next one. If I were you, I would pause it and make sure that you can do this one on your own and then go back and play the video. So the density of nitrogen gas is what I'm trying to find here. So like I said, maybe pause it and then click play again when you're done. All right, so the density of nitrogen gas is the molar mass over 22.4 liters, which means I need the molar mass of nitrogen gas. This is where you have to remember that nitrogen gas is one of those diatomic molecules. So if you paused it, maybe you used 14, but the molar mass of nitrogen gas is actually 28 grams. So the density is 28.0 grams divided by 22.4 liters. Which gives me exactly 1.25 grams per liter. All right, so hopefully that helps you with today's assignment. Today we took a look at what molar volume is. We looked at our Y diagram and how to calculate or complete some of those conversions. We took a look at some two-step conversions. And then you learned how to calculate the density of a gas. All right, so your assignment then for this off-campus day is to complete this worksheet. If you look at it, you've got a few different parts here. The top, you're just converting moles into liters. For number 2, you're converting liters into moles. For number 3, you are finding the density. For 4 and 5, these are going to be two-step conversions of some kind. I can tell because it's asking for the mass of a volume. That's going to take me a couple steps. And then when I get to the back, these are also all going to be 2 steps on the back, I believe. All right, like for number 6, you should start with 1 magnesium atom. And then you are going to go atoms into moles, moles into grams. This is going to be a really small number because I'm looking for the mass of 1 atom. That's going to be really small. All right, and it's similar down here on these last 3. Alrighty, so again, please answer the question in the forum that's asked, and then work on this for your homework. And I will see you on Wednesday.